Hello, good evening, and good morning. This is your host, Mike Espina. Welcome to Math Agility Live. This is our new platform where students can send in their math homework problems to our social media channels, and we will answer them via Facebook Live every Tuesday and Thursday from 6 p.m. to 8 p.m. That is PST, and Wednesday and Friday, 9 a.m. to 11 a.m. Manila time. Let's go now to the first question. Apparently, my Apple Pencil was unpaired from my iPad, uh, where my virtual board is. So okay, so let's now. Okay, let me share my screen to you again. Okay, so this is the first question of Singapore math, and uh, this is from fractions of different sets. So let's read the problem again. Um, Ryan had some blue and green buttons. 3/7 of the buttons were blue, and the rest were green. He gave away 2/5 of his buttons, and then 80% of the buttons given away were blue. 2/3 of the buttons were left green. How many buttons did Ryan have altogether at first? So I'm gonna use first how will my own method of solving this. So if you were here or if you watched last time's Singapore math session, I'm using actually the table method. So first we have the blue, right, and green. And then it says 3/7 of the buttons were blue. So, okay, let's first designate or represent X as the total number of buttons, right? And then for B, it says 3/7 of X. Since X is the total number of buttons and it says 3/7 is blue, therefore 4/7 would be the green one, right? Okay. And then the second part of the sentence says he gave away 2/5 of his buttons, right? So this is the amount he gave. So he gave 2/5, 2/5 of X, right? So this is what left for Ryan's total number of buttons. So let's keep this. So this would mean the total number would be X, right? Minus 2/5 of X. So this would be 3/5 of X is left, right? Okay, so now let's read the third part of the third sentence of the question. So 80 of the buttons given away were blue. So 80, so from the 2/5 that he gave, so he gave 2/5 of X. So let's write a little bit here. So 2/5 X is actually 80 blue. And of course, there would be green, right? We don't know how many, right? So, and then it says there 2/3 of the buttons were green. So, this case, it's not given in absolute number like the one in blue buttons, which is 80. So, what we can do is that we can represent it, uh, the green one as again a percentage with the variable x. So, we know the 3/5 x. So, 3/5 of x. And if we get the 2/3 of that, it says this is the number of the the green buttons that was left. Okay, so basically we're just multiplying this. So 6/15 of x, right? So this we know is the green buttons, right? Okay, so again, so we can also deduce that if 2/3 were given from what is left, therefore 1/3 of this 3/5 of x would be your blue, right? So again, let's multiply this. It's just 3/15 of x. So we know from what is left that is blue, right? So what can we say for the blue buttons? So we know that if we add what is left, so this could be simplified, right? So 1 over 5 of x. So what we can say about the blue buttons is that if we add the 80 buttons, right, plus 1/5 of x, that should be equal to the amount, total amount, right, of the total number of buttons, which is 3/7 of x here, right? So 3/7 of x. So let's write it here. So now we can see from this equation that um, we can actually solve for x, right? So we can easily um, move, okay, so 3/7 of x minus 1/5 of x, and then this is 80, right? Then we can just combine this two, which would give us 8x over 35, right? 80. So this would be, if we divide it by 8 on both sides, this would be x over 35 times 8 times 10. Sorry. So this would be times 10. And then x now would be equal to 35 times 10, which is total of 350. So initially, the number of buttons would be 350 buttons, right? So that is the question being asked actually. All right, so we have 350 buttons here, right? Okay. So let's show how okay, do you see this in your screen? Okay. Let's show how Singapore Math solved this problem. So I want your honest opinion. Which one is better? My methodology of solving this using variables, or the Singapore Math? So, okay, so let's go to the page where it shows the solution for. So this is the Singapore way of solving this. So first, he uh, he represented the blue buttons as, of course, we said it's 3/7, right, of x, without using any variable x, and then he converted into since the okay, so the reason why he multiply it by 5 is because of this figure here. So 2/5, so he multiplied both by 2/5, so the common denominator would be 35, right? So given away is 2/5, so if you again multiply this by 5, this would be by 7 on the numerator, and by, yeah, sorry, yes, and then this one is by 5, this one is by 7, this one is multiplied by 5, so this is 15 over 35, and this is 14 over 35. So and then what is left, of course, we need to subtract the the the, the buttons he given away from 1. So 1 minus 14 over 35 equals 21 over 35. So 21 over 35 is what left from the number of buttons. So green buttons left would be, it says, is 2/3, right? Here from this information, 2/3 of what is left. So 2/3 times 21 times 21 over 35. So it's 14 over 35. And then for the blue buttons left, so we need to subtract 21 over 35. So what is left? Minus the green buttons. So that is 7 over 35. And then the blue buttons given away is 15 over 35. So this is the initial minus 7 over 35. So that is 8 over 35. And we know that the blue buttons given away is equal to 80. So he wrote this. 8 over 35 buttons is 80, and 1 over 35 buttons is actually 10. So basically dividing by 8. So 1 over 35 is 10. So multiplying these buttons is equal to 10 times 35 is equal to 350. So altogether, the buttons that was initially the number of buttons are 350. Okay, so there you go. There's a similarity on the solution, um, but they rely heavily on ratio and proportion and fraction. That's what I noticed. You can also write your comments in the comment section below. How do you find the method or the way I'm solving this and the Singapore method of solving this question? Okay. Okay. So and if you have any questions, you can also write in the comment section, of course. And then let's move to the second question. So the second question is about finding relationships. Okay, so this is not the relationship all of you are thinking about, but this is about mathematics, finding relationship uh, between variables. Okay, so let's read the question. Caden and John had some marbles. John gave away 3/5 as many marbles as Caden and was left with four fewer marbles than the marbles he gave away. Caden had 2/5 as many marbles left as John. The difference between the number of marbles they had in the end was 21. How many marbles did Caden have at first? Okay, this is how I'm gonna solve this again using the table method. So let's write here John, and then who's the other guy? Caden, right? Okay, so um actually in this problem I use three variables. So bear with me. So marbles. So the marbles that John initially had is X, right? And Caden had only Y marbles, and then he gave 3/5 of Z marbles. Okay, so I write it Z for the number of marbles given away by Caden. So Caden had given Z, and then John gave 3/5 of that amount of Caden's marbles. Um, yeah, Caden marbles given away, and then uh, so what is left? It says there is uh, with fewer marbles than the marbles he gave away. So this would become X minus 3/5 of Z, right? And then this would remain Y minus Z, right? Because he gave away Z number of marbles. And then it says on the last part of the second sentence that what was left to John was four fewer marbles than the marbles he gave away. So when he gave away 3/5 Z, this would be minus 4, right? So is equal to 4. Okay, so now let's go. So Caden had 2/5 as marbles left as John. So what was left with John is X minus 3/5 of Z. So this Y minus Z, the number of marbles left with Caden, is actually equal to 3/5, or 2/5, not 3/5, 2/5. So Y minus Z, let's write it here. So Y minus Z is equal to 2/5 of X minus 3/5 of Z, right? So so we can deduce that if 2/5 what was the number of marbles left to Caden, therefore John has actually 3/5, right? Of this. So 3/5 of X minus 3 Z over 5 And it says here, what else is that? So the difference between the marbles they had in the end was 21. I'm sorry. So if you take the difference of the what was left to John and Caden is 21. So this would be the case. 2/5 and then 3/5 of that is equal to 21. So this means we can distribute 3/5 of x right here and this one here. So 3/5 x minus 9/25 of z is equal to 21. Okay, so let's say this is equation 2, and let's say the first equation we had is equation 1 here. So this is my equation 1, equation 2. So again, from equation 1, so this is x oops, let me just write it again. So this would be x minus 3/5 of z, right, is equal 3/5 of z minus 4. And so this is actually from the first equation here. Let me check it here. So I wrote it again here to simplify this. So if we try to simplify this would be x equals 6/5 of z minus 4. And I would name this equation 3. Okay, so now we have three equations, equation 1, equation 2, and equation 3. So let's, so now we can actually eliminate x by substituting equation 3 to equation 2, right? So let's do that. So equation 3 in equation 2. So what is equation 2? It's 3/5 of x. So this is now our x. We eliminate the value of x or the variable x from the equation minus, what's this value here? 9/25z is equal to 21, right? Okay, so let's distribute 3 pips here. So this would be 18/25z. And then the other one here, which is negative 12/5. And then minus 9/25z equals 21. So we can combine like terms, right? Combining like terms for z. So this would be 9/25z. So 21. So let's transpose 12/5 to the right-hand side of the equation. So this would be plus 12. So when we transpose a negative number, that becomes positive if you transpose it to the other side of the equation. So if you notice, this is negative and this becomes positive when I transposed it. Okay, so now let's combine these two. This would give us 117/5. And this would be still 9z/25. So we can do cross multiplication. So this would give a z is equal to 65. So now we have the value for z. And what is z stands for? This is actually what Caden gave, the number of marbles Caden gave. So now we can solve for x, right? So in equation 3, sorry. So in equation 3, let's substitute. So this is what Caden gave. So in equation 3, so this is x equals 6/5 of 65 minus 4. So what is x? If we go back to our table, x is actually what John gave. The marbles, total marbles of John initially. So this is total of 74. So this is John's initial number of marbles, okay? Okay, so now let's try to solve for y, which is the actually what we need to find, the number of cadence marble originally, right? So let's try to substitute y, z plus 2/5 of x minus 3/5 of z, right? So we know z and x. So x is 74 and z is 65. Okay. So let's substitute. So z is 65 plus 2/5 of x, which is 74 minus 3/5 of 65. Okay, so when we try to find the value of this, combining everything, this will give us 79. So y is 79. So this is the cadence total number of marbles. Okay, so it's so in this question, I've used three equation and three unknowns. Okay, so let's see how Singapore math solved this question. So mine is kind of longer. So let's see how they solve this. So this is the Singapore method of solving. Again, they never used any variable. They just put everything in units. So it says here difference in units between Caden and John in the end is 5 minus 5 minus 2. So 5 is the unit of so Caden. So he used this ratio here. Caden is to John. So 2 over 5. So if you subtract John, so the difference between John and Caden, so he used 5 minus 2 is 3 units. So in terms of units, so this is that case. And then he actually did the subtraction because of this sentence here. It says the difference between the number of marbles they had in the end was 21. So if you subtract this ratio, it should be 3 units. And that 3 units is actually 21. So, oops. So 21 divided by 3 is actually this. So 1 unit is equal to 7. So Caden left. So this is 2. So 2 times 7, that's 14 here. And then the number of marbles for John is 5. So 5 is 7 times 5 would be 35. So it says there at the second sentence, the last part of it is the 4 marbles, right? He has a fewer marbles than the marbles he gave away. So John gave away 35 plus 4, which is 39 because he gave it away, right? So we're counting the negative. So we're adding 35 from what was hold on. So and was left with, yeah, 4 fewer marbles. And then John gave away to Caden, to what Caden gave away is 3/5. So this is that information. So 3 units. So 3 times, so that is 39. And then the 5 is, so that would be 65. What's that? So 39, 65 divided by 5 is, yeah, 13. So times 13, 15, 5 times 13, and then 3 times 13. So he got 39 is to 65. So the 14 that Caden left plus the 65 that he gave away. So here plus 65 is 79. So Caden had originally have 79 marbles. Okay. I think this is easier than how I approach the problem. So let me see. please comment on the comment section below. How did you find the Singapore math solution and my solution to this problem? Okay, so let's go to the third question, and this is about redistribution. So let's read the problem. Mr. Po had some pencils for his class. If he gave each student 7 pencils, then he would have 8 pencils left. If he gave each student 9 pencils, then the last 3 students would have only 5 pencils each. How many pencils did Mr. Po have? Okay, so this is question number 3, and we have actually 10 questions to solve for today. If we have time, okay, we still have time. Okay, so again, I'm gonna use the variable, the representation method of algebra. So I will let x or x equal to number of pencils, and then I would let y equal to number of students, right? Okay, so it says there, if he gave each student 7 pencils, so we don't know the number of students and the number of pencils. That's why we represented it by x and y. So this first equation would be x representing this sentence here, the first part of the second sentence. So x minus 7y, 7 times y, and what was left is 8 pencils, right? So let's say this is equation 1, okay? And of course, what is the second part? Oh, okay, so we move to the third sentence. So if he gave each student 9 pencils, then the last 3 students would have only 5 pencils each. So if I subtract x and then 9 times y minus 3, it says that each would have only 3 pencils left. 3 students would have 5 pencils each. So 3 times 15, 3 times 5. 3 times 5, what was left to Mr. Po. So let's try to distribute or simplify this. So this would be x minus 9y plus 27 equals 15. Okay, so again, let's transpose 27 to the right-hand side. So 15 minus 27. So this would be x minus 9y equals negative 12. So let's name this equation 2. So we have already 2 equations. The first equation is x minus 7y equals 8. And then the second equation is x minus 9y equals negative 12. Okay. And then what's the next step? Of course, we need to eliminate some variables. So if we subtract equation 2 from equation 1, so I mean equation 1 to equation 2, so equation 2 minus equation 1. So our equation 2 is x minus 9y equals negative 12, right? This is our equation 2 minus our equation 1, which is x minus 7y, right? Equals 8. Let's double check. Yes, so x minus 7y equals 12. So let's try to subtract this. So x minus x would be 0, right? Negative 9y plus 7y would be negative 2y, right? And then negative 12 minus 8 would be negative 20. Okay, so let's divide this both sides by negative 2. So we have y is equal to 10. So there are actually 10 students or 10 pupils. And then let's try to find x. So x is from equation 1, x is actually 8 plus 7y, right? This is from equation 1. So 8 plus 7 times 10. So this is 78, right? So there are actually initially 78 pencils. Okay, so this is how I'm going to solve this problem. If you have any questions, please write down at the comment section of our Facebook page or in our Instagram and our Twitter account. Okay, so let's see how Singapore Math would answer this kind of problem. So let's move to the next slide. So it says here 9 minus 5 equals 4. Again, it's based on units. And so the last three students were short of 4 pencils each. So initially it was 9 minus, so 4 and then 3. So the 3 here is the number of students multiplied by 4, which is the number of pencils. So you have 12. They were short of 12 pencils in all. So for the 3 students, they were short of 4 because originally it was 9, right? So 9 minus 5 equals 4. And then 8. So we have 8 plus 12. So from the first part of the second sentence, it says there that they had 8 pencils left. So 8 plus 12 would be 20. And then in the next line, 9 minus 7 is equal to 2. So from they have, what is this? So 7, 9 minus 7 equals 2. And then from the 20, they divide it into 2. So they have 10. So there were 10 students, right? So from for the first sentence of the second, the second sentence, first part of the second sentence, it says there's 7, right? 7 students would get 7 pencils. So 7 times 10 from the students we computed here. And then the 8 pencils that was left, right? So 7 times 10 plus 8 equals to 78. So Mr. Po had 78 pencils initially. Okay. What do you, which do you think is easier to understand, the way I'm solving it or the Singapore method of solving this question? Okay. Okay, let's move to problem number 4. Okay, so problem number 4 is about percentage of different base. So let's read the problem. So Terence spent 20% of his savings on a watch and 30% of the remainder on a wallet. He had $840 left. What was the amount of money Terence had at first? So, okay, so again, I'm using the representation method. So X would be the savings of Terence, right? And what else? So it says there 20% were spent on the watch. So 20% of X was spent on the watch, and then 30% of the remainder. So what is the remainder of this? So X minus 20% of X would be 80% of X, right? So this is the remainder because this is 100%, right? This is 100% initially. So if you want it X minus 0.2 in decimal form, so this is 0.8 X, right? So this is the remainder. Okay, so it says there 30% of the remainder was used on the wallet. So 30% of the remainder. So 30% of 0.8x spent on a wallet. So he spent 20% on the watch, and then 30% of the remainder was spent on the wallet. So, and then he had $840 left. So what was left is 70%, right? 70%. of 0.8x is actually the amount that was left, and it says that he had $840 left. So this would be equal to $840. Now from this equation, we can solve the value of x, which is the amount of savings of Terence. So let's try to put this in decimal form. So 0.7 times 0.8x equals 840. So this would be 0.56x was 840. Then let's divide both sides by 0.56. So this would be x is equal to $1,500. So this is the original amount, sorry, the initial money that Terence has, or the savings he has. Okay, so we solve this problem. Let's see how Singapore Math solved this question. Okay, so he did first subtract the number of percentage he spent on a watch. So 100% minus 20 would be 80%. And then subtract the amount of the remainder he spent on a wallet, which is 30. So he got 70% here. And then he multiplied the 80% and the 80%, 70 and 80% together. So he got 56% here. And he relate the 56% to 840. So this is that line here. And then 1% of 840 is divided by 56 is $15. So 100% of $15 times 100 is actually $15 times 100 is $1,500. So we got the same. Of course, we have the same answer, but on a different way of representing the variables. Actually, he didn't. The Singapore Math didn't put any representation. He just used proportion or the percentage of the savings or the variable being asked on this question. Okay, so again, if you would kindly feedback, please comment which one do you think is easier, the Singapore Math method or the method I've shown to you earlier. All right, so now we move to the fifth question. Okay, so now we move to percentage comparison. So here is the question. So the width of a rectangle is 60% shorter than the length of a rectangle. Given that the perimeter of the rectangle is 140 centimeters, find the width of the rectangle. Okay, so this kind of problem is actually famous or really common when it comes to perimeter problem or area problem, right? So, okay, let's use again the table method. So length is x, and then the width is x minus 60%, right? Because it says they're shorter by 60%. So this would become 40% x or 0.4x in decimal form, right? So we learned that perimeter is actually equal to twice the length plus twice the width, right? So if you draw a rectangle, so this is the length, width, right? So that's why it becomes 2L because of two lengths here, and then the 2W because of the 2W here on both sides of the rectangle. So we say that the length is x, so let's substitute this variable. So instead of using L, we're actually using x, and then our W is 0.4x here. So 2 times 0.4x, right? So this is perimeter. So, and okay, so we have another information on the second sentence. So given the perimeter of the rectangle. So the perimeter of the rectangle is given, which is 140 centimeters. So we can equate this from here. So 140 is equal to 2x plus 0.8x. So this is 2.8x is to 140, right? So how do we solve the value of x? Of course, we will eliminate 2.8. So we need to divide this 2.8 on both sides of the equation. So x would become equal to 50. So what did we say is x? So this is the length of the rectangle, right? And how we compute the width? So it says the width is 0.4x. So 0.4 times 50 is equal to 20. 20 centimeters, and this is 50 centimeters. So this is the width. Okay. So this is how I will solve this kind of problem. And now let's see how Singapore Math will solve this kind of problem. Okay, so let's go to the next slide. So, so again, it's more on the proportion or percentage instead of variable. So length is given here as 100%, and then width, of course, is shorter by 60%. So uh, it subtracted 60% from 100. So we have 40%, right? And of course, this is the formula for perimeter. 2 times length plus width, or simply P is 2L plus 2 width, right? And then one set of length and width is actually equal to 140 centimeter. So we divide it by 2. So that would be 70 centimeters for one set. So 100% times plus 40 is 140%. So 140% of length. So length plus width to 70 centimeters. So width would definitely be 40% of length, which is this information that we have. So that is 40 over 140 times 70. We got 20 centimeters. And of course, the width of the rectangle would be equal to this. Okay. So if you have any questions, please write down in our comment section on our Facebook page and our Instagram and Twitter account. Okay, so let's move to the sixth question. This question is about percentage change. So let's read the problem. So in a school, there were 20 male teachers and 60 female teachers. Female teachers left the school and 7 female teachers joined the school. Find the percentage increase in the number of teachers in the school. So initially, what do they have? Initially, or originally, we have a male of how many? 20, and then female of 60. So total is 80 teachers, right? Initially. Okay, so it says there on the second part of the sentence, it says 3 male teachers left. So we subtract left. So this would become 17, right? And it says the 7 female teachers joined. So instead of left, we add 7. So this becomes 67, right? So if we try to total this, 60 minus 3. Yeah, tama. This is correct. And this is 1484, right? 34. So now, so this is now. Okay, so the question is, find the percentage increase in the number of teachers in the school. So initially you have this 80, and that becomes 84, right? So that was the increase. It increased by 4. So 4 divided by, so 84. So percentage increase is 84 minus 80 from the initial number of 80. Oops. So this would be 4 over 80, and this would be equal to 5%. Okay, so there is a 5% increase. All right, so let's go how Singapore Math will solve this kind of problem. So let's see. Okay, so it's given here, original number of teachers is 20 plus 60, right? So this is the 20 male teachers and the 60 male teachers. Check. And of course, adding it together, it would give us 80. So again, based on percentage and proportion, he equate 100% to 80 teachers. And then increase in the number of teachers would be uh, 7 minus 3, which is the number of female teachers joined minus the number of male teachers left. So 7 minus 3 would become 4, right? So this number of 4 uh, is what part of 80? So that's what is showing here. So 4 over 80 times 100% is 5%. So it's kind of similar on how we solve it. The only difference is there's no use of, again, representation or variable, okay, in Singapore Math. Okay, so let's move to question number 7. Okay, and of course, if you have any questions, please, or I want your honest opinion or your feedback. Which one do you think is easier to understand? Is it the Singapore Math method or the method I'm using, which is more on variables and tables? Okay, so let's go to problem number 7, and this is volume of a cube. The topic here is volume of a cube. So let's read the problem. The length of cube X is 2 times the length of cube Y. The volume of cube Y is 27 cubic centimeter. What is the volume of cube X? So again, so change my, so we have two cubes. One is cube X and one is cube Y. So cube Y, let's say, is A, right? And then cube X is, so I'm representing the length, sorry. Length is A for cube Y, and it says cube X is 2 times the length of cube Y. So we multiplied A by 2, right? So that's the length of cube X. And then it's given that the volume, so there's a given volume. For cube Y, it's 27, right? Cubic centimeter. And we need to solve for the volume of cube X. So that's question mark. So how can we solve this? So for cube Y, let's solve this first. So volume is actually A times A times A, right? So if we try to draw a cube, so all of these sides, the length, the width, and the height would be all equal to A, right? Which is the length. Okay, so that's why it's A times A times A. So this would give us A cube. And it's given that the volume of cube Y is 27. So we can solve the value of A here. So let's substitute the 27 to A. To this equation, I mean, so A would be equal to 3. 3 centimeter, right? Let me fix this. So 3 centimeter. Okay. So now how will we solve for the volume of cube X? So since it has a length of 2a. So let's cube x. So this, it's bigger, twice bigger than cube y. So let's try to draw it bigger than cube y. So this would be 2a. So this length here, again, this would be 2a, the length here, or the width, and then the height, which is from here up to here, would be 2a again. So the volume of x would be 2a times 2a times 2a. So length, width, and height, right? So this would give us 8a cube, right? And since we know the value of a from cube y, so 8 times 3 cube. 3 cube is time. So what's this value? 3 cube times 8 would give us 216. So the volume of cube x is 216 cubic centimeter. Okay, so this is the method that I will use in solving this problem. Again, let's try to see how Singapore Math will solve this. So let's go to the next page. So volume of a cube. So it's shown here that um, volume of cube y is 27. So uh, he actually assumed, or we know that since a cube is a cube, or in three, it's actually the variable a times a, right, on our previous calculation. So to get the value 27, when we try to get the cube root of 27, that would give us 3. So it means 3 times 3 times 3 would be the root of the cube root of 27 would be the triple threes, right? Which is this. And then length of one side of cube y is definitely 3, right? And then it says here cube x, since it's twice the length of cube y, so 2 times 3 would be 6 centimeters. So the volume of cube x would be, again, the triple 6 times 6, or 6 cube, would give it 216 cubic centimeter. So the answer is 216 cubic centimeter. Okay. So please, again, comment which is easier to understand or easier method in solving this question, the volume of a cube. Okay. You can write it down at our comment section, please, below. And then let's go to question number 8. So question number 8 is about rate. So let's read the problem. James took 4 hours to clean the fridge, and then Brian took 12 hours to clean an identical fridge. If both of them work together, okay, so how long would they need to clean the fridge? So typically this is called a work problem. So again, let's use the table method. So James, and the other guy is Brian. So it says that James would take 4 hours to clean the fridge, and then Brian would take 12 hours to clean the fridge. Okay, so if they would work together, how long they need to clean the fridge? So let's say X would be the total number of hours to clean the fridge together, right? By number of hours to clean the fridge together by James and Brian. Okay, so this means that this would be 1/4 of x, right? And this means that 1/12 of x. So if we try to add this together, so 1/4 of x plus 1/12 of x should be 1, right? Because it's the whole. So 1/4. So let's try to factor out x. And then let's solve 1/4 plus 1/12. So, oops, common denominator would be 12. So this is 12 divided by 4. If you still remember your fractions, so 12 divided by 4 is 3 times 1 would give us 3. And then 12 divided by 12 is 1 times 1 here is 1. So x plus 1. So 3 plus 1 is 4 over 12 times x equals 1, right? And therefore, 1 over x is 1 over 3. Therefore, x is 3 hours. So if they work together, they can, oops, you can see in my, if they work together, they would require 3 hours cleaning the fridge. Okay, so this is the method I will use when I solve this kind of work problem or rate problem. Let's see how Singapore Math would solve this. Okay, so in 1 hour, it says here James could clean 1/4 of the fridge. Okay, so again, this is based on proportion or percentage, and then Brian could clean it 1/12, right? If it's 1 hour. So if you combine 1/4 plus 1/12, so that's 3 over 12 plus 1/12, getting the common denominator of 12, that's 4 over 12. So in total, that is 1/3. So, and then Cesar, James, and Brian could clean 1/3 of the fridge in 1 hour. So 1/3 of the fridge, 1 hour, right? The both of them. So 3 of 3 would be 3 hours, right? So one. So it actually, if this is your fridge, it actually subdivided the fridge into 3. So this would require 1 hour working together, 1 hour for working together, 1 hour working together. So that means it is 3 hours to clean the fridge, the whole fridge. So that's how Singapore would solve this. Singapore Math would solve this. Okay, again, please comment which do you think is easier method in solving this kind of problem. All right, let's move to the next problem. So this is sum of consecutive numbers. Okay, again, this is very common problem given in algebra classes. So I think this is also an easy question here. So the average of 3 consecutive even numbers is 50. What is the largest of the 3 numbers? So again, my method is representation. So I would represent first x, my smallest number. X plus 2 would be the next number or middle number. And then x plus 4 would be the largest number, right? So it says here average. So when we get the average, we actually sum it up and then divide the number of elements, so or the number of samples. So we have 3 samples here. So this is first number, second number, and third number. So we definitely need to divide the total by 3, right? So we know that this is 3, and then we try to add x, the first smallest number, x plus 2, the middle number, and then x plus 4, the largest number. And it says here that this average is 50, right? Okay, so let's try to simplify this. So x, so combining like terms, so x would be 3x, and then 2 plus 4 here would be 6, right? Divide by 3 equals 50. So we can see there's a common term of 3. If we factor out 3 here, x plus 2, right? Divided by 3. So 3 cancels out. So we have x plus 2 equals 50. So x 50 minus 2 is 48, right? So we know that the smallest number is 48. But the question here is what? What is the largest number? And you represented the largest number as x plus 4. So we should add 4 to 48. So x plus 4 is 48 plus 4. Of course, this is 52. So 52 is our largest number. Okay, so let's see how Singapore Math would solve this kind of problem, consecutive number problem. Okay, so again, he uses proportion, or so total sum is 3 times 50, because if you divide 150, that would give you an average of 50, right? So that's the first thing he did, and then he represented into a visual representation of a smallest number. So the first one is this long. Medium would be another plus 2 units here. And then the largest would be 2 plus 2, or 4 units. And the total of this would be 150, right? If you sum up the smallest, the medium, and the largest, that would be 150. So if you try to subtract all the excess of 2 and 2 and 2, this first 2, second 2, and the third 2, you would have 144, right? So 144, if you divide it by the three numbers, small 1, the smallest, the 2, the medium, and largest, you would get 48 as your smallest number. So again, it's similar to 48 plus 2, since we know that this length is 48. And then plus 2 here, this should give you 52. Okay, so he turned, Singapore Math turned it into more visual when computing consecutive numbers. All right, if you have questions, please write down at the comment section of our Facebook page. And our last question is question number 10. So this is about advanced transfer, okay? So let's read the problem. So Amy and Ben had the same amount of money at first. When Amy gave Ben $36, 50% of the amount of money Amy had left was the same as 75% of what Ben had left. Okay? So, okay. How much did they have in total? So, this is how I'm going to solve this again. So, let's say Amy and Ben. So, the table representation had an X money and Ben had Y money. Okay? So, when Amy gave Ben $36, so when you subtract these two together, X minus Y, the difference should be 36, right? Because Amy gave 36 to Ben. So if you try to subtract their both the money of this two person, that the difference would be 36, right? Okay, so next part of the sentence is, it says 50% of the amount of money Amy had left. So how much did Amy had? So left is X minus 36, right? So 50% of that is actually 75%, same as 75% of what Ben had left. So 75% of what Ben had left is equal to y, right? So let's distribute 50% and here. So this would be 0.5x. What's the 50% of 3618? And this would be 0.75y. So we have actually two equations, right? So this one, the first equation is this. Equation 1, x minus y equals 36. And then let's rearrange this in terms of x. So I would write y equals 0.5x minus 18 divided by 0.75. So let's say this is equation 2. So let's substitute equation 2 to equation 1. So equation 2 in equation 1, right? Okay, so x minus y. So originally it's x minus y equals 36. So this would be x minus 0.5x minus 18 over 0.75, right? Equals 36. So this would give us 0. So I multiplied everything by 0.75. So 0.75x minus 0.5x minus 18, plus 18, right? Because this is negative, equals 27. So let's transpose constants to the right. And let's combine first these two. So this would be 0.25x. And let's transpose 18 to the left, to the right-hand side of the equation. So the positive becomes negative, right? When we transpose numbers. So this would be 0.25x equals, hold on. So is this 0? Why this becomes, hold on, let me double check. This would be negative. This would be positive. Okay, let's see. 27 minus 18 is 9 divided by 0.25. 36. Okay, let's see how, oops, sorry. I got a different answer from solution of Singapore math actually. Let's see. Where did I messed up here? So 50% of x minus 36.5 and then minus 18. Okay. Actually, I got 9 here and x is 36, but it should be 45. Okay, let's see. Later I would comment why I got this a different answer. So let's go to Singapore math. So 50% of Ami's money is equal to 75% of Ben's money here. So it translated 50% into fractions, so that's 1/2, and then translate 75% equals 3/4 of Ben's money. So multiply this left-hand side by 3, so 1/2 times 3 over 3, so that's 3 over 6 here. And Then that equals equal to 3 over 4 of Ben's money. So Amy is to Ben is 6. The denominator here. So it's 6 is to 4. And then the numerator. Okay. And then we call this get the common factor. So divide by 2. So this is 3 over 2. Oops. 3 over 2 here. So the difference in the end is 1 unit is 36 times 2, right? So that would give you $72. And then the 5 units at first, so 3 plus 2. So 2 units, and then 3 is this. So 3 plus 2 is 5. So at first, they have 5 units. So 5 times 72 is 360. Total at first is equal to the total in end as no money was given away to a third party. So the money just revolves between the two person. And therefore, Amy and Ben had $360 in total at first. Okay, so that's the last problem we will be solving today. If you have any questions or comments, please write it down at our Facebook page or our Instagram or Twitter account. And next week, so this Thursday, we won't have any Math Agility Live, but next Thursday, we would be solving some differential equation problems. Okay. So, okay, there you go. Hope you learned something from me today. So we compared Singapore math methodology based on the methodology I'm using, which is more of representation and using table. And thank you for everyone for watching today. So please send in your question. So the questions that was sent from Monday to Wednesday. Um, Again, since we don't have on Thursday, we will be presenting them on Tuesday next week. And hope to see you again next Tuesday. God bless everyone and stay safe.